All right, example 8. A student council consists of 9 girls and 7 boys. A subcommittee of 5 students will be formed to help out with the upcoming dance. Determine the probability that there will be at least one boy. Okay, so I'm just going to say at least one boy. Don't write this down. Just listen to what I'm going to say. And if you're one of those people who are going to take notes and not watch the video, this might hurt. So at least one boy. So what I could do is I could figure out a way, like at least one boy. I could say, well, I'm going to figure out the probability of one boy, and then 2 boys, and then 3 boys, right? And then 4 boys, and then 5 boys, and then 6 boys, and then 7 boys. Do you see how long? That would have to be 7 different calculations. That seems very, very rigorous. I should probably look for an easier way. Now, what is the complement of having at least one boy? The complement of having at least one boy is no boys. Oh, okay. So the probability of having at least one boy is going to be equal to 1 minus the probability of having no boys. Now, having no boys, what do I mean? All girls, maybe. Those two things are the same thing. Having no boys, all girls, that's fair enough, right? So here, I'm just going to say 1 minus. What is the probability of having all girls? Well, I'm forming a subcommittee, 5 people, and I'm going to say, how many ways is there to choose nothing but girls? Well, I have 9 people to choose from, right? And I'm choosing 5 of them, or choosing 5 from 9, and that's going to be 9 choose 5. Divided by, well, what are the number of total different arrangements I have? Well, I have a total of 16 people. So 16 choose 5. And this is the time to break out my calculator. My calculator is super awesome. And what I get is the probability of choosing a subcommittee with at least one boy is going to be 0.971. All right. Last example. You've really muscled it out over the last little bit here. There are 5 jazz dancers and 7 ballet dancers, from which 4 dancers are chosen from random to choosing a group. Now, the number of ways 4 dancers can be chosen. Okay, so I have a total of 12 dancers. So I'm going to choose 4 at random. How many different ways are there to choose them? Well, I'm choosing 4 dancers from 12. So that is, in my calculator, I can figure it out, 495. Determine the probability that I pick 4 jazz dancers. Now, the probability of picking all jazz dancers, or 4 jazz, actually, I like all jazz. That may be all jazz, is going to be, well, now this is the probability, so I'm still picking 4 people from a group of 12. The probability that everybody's a jazz dancer, I'm choosing from a group of 5 jazz dancers, I'm choosing 4 of them. So it would be 5 choose 4 divided by 12 choose 4. And what I get is this is 5 over 495. And that is going to be equal to Pardon me, I made a mistake there. 0.0101. Okay. Let's move on to C. Determine the probability that at least one ballet dancer will be chosen. So if I'm choosing at least one ballet dancer, I could figure out the probability of one ballet dancer, of two ballet dancers, of three ballet dancers, of four. Now, that would take a long time. Well, what's the complement of choosing at least one ballet dancer? The complement is all jazz. So really, the probability of choosing at least one ballet dancer ballet is going to be 1 minus the probability of all jazz. And that is going to be equal to 1 minus 0.0101. Exactly, we figured out the probability of having all jazz. And that is going to lead me to the probability of 0.9899. All right, I encourage you to ask questions about this. Try to be very specific about where you're going or what you're having difficulty with. I will be available to answer your questions.